Hello and welcome to week 2 for Statistics 201. In this video we're going to talk about chapter 3 from the textbook, and here's the chapter contents. And what we're doing here is describing data visually, so you can see there's lots of different things we've got: stem and leaf displays, dot plots, frequency distributions, histograms, all sorts of different Excel charts, line charts, bar charts, pie charts, scatter plots, tables, and then some deceptive graphs. So we're going to go through this relatively quickly. You should have read the text by now, chapter 3, so we'll kind of just hit some of the highlights here. And if you have any questions about any of this stuff, please don't hesitate to send me an email to ask your questions. Here are the learning objectives for Chapter 3, at least the first of them, and the remaining learning objectives for each of the sections. So there are two methods for organizing and exploring and summarizing data. These include visuals, things like charts and graphs, and numerical methods such as statistics or tables. So in this chapter we're going to talk about both of those things, starting with the visual. More specifically, we're going to look at stem and leaf displays and dot plots. In order to do this, we first have to talk about a few characteristics of univariate data. So we're talking about a single variable, and we have n observations. So the first thing we need to know is what kind of measurement do we have, what are the units, what are, is it continuous, is it discrete, are there missing observations, are there any other concerns that we need to deal with. The center of the data is the measure of just what it says, the center or measure of location. Variability tells us how much dispersion there is in the data. And the shape of the data tells us whether we have skewed, symmetric, flat, peaked, bimodal, and so forth. For the measurement, what we're going to do is look at the data and visualize how they were collected and measured. Then we're going to sort the data, and as an example we're going to look at the price to earnings ratios for a bunch of stocks. And here they are. We've got 44 sorted price to earnings ratios, so 7 is the low and 59 is the high. So the type of graph we're going to use depends on the type of data we have. Some charts are better suited for quantitative, and some are better for categorical or qualitative data. And the simplest one we're going to use is what's called a stem and leaf plot. And this is a very simple way to summarize or to visualize our data. And this is an example of something called exploratory data analysis, or EDA, and that helps us to see very quickly what's going on with the data set. So basically what we're going to do is we're going to do a frequency count and arrange that in a special way where the stem is the tens digit of the data and the leaf is the ones digit. If we had hundreds digits and thousands, then we would do something slightly different. But here we go. This is the stem and leaf display. Notice that we have 7 and 9. Those are the two smallest data values, and so the stem is 0, 0 tens, 7 ones, 9 ones. So that represents 2 data points. We have a frequency count over here. And then we had how many tens? 1, 2, 3, 4 tens, 1, 2, 3 11s, 1 12, 3 13s, 2 14s, 1 15, 4 16s, 2 7s, 2 8s, and 2 9s. And those are all preceded by a 10, so it would be 2 19s and so forth. So we get an idea of what's going on here. We got a whole bunch of stuff right in the 10s and 20s, and a couple things out here in the 50s, only one in the 40s, and a handful other places. Next we're going to look at what's called a dot plot, and this is the simplest graphical display, and basically all we're going to do is represent each point with a dot. So here's the steps. First we're going to make a scale that covers the data range. Then we're going to mark the axes and label. And then we're going to plot each data value as a dot above the scale at its approximate location. And if more than one data value lies at the same axis location, then we're going to stack the dots vertically. So here's an example of a dot plot. You can see we've got 44 observations, and notice that we have how many 10s? There are 4 10s, there are 4 16s, 3 11s, 3 13s, and so this gives us an idea of how frequent each of these things occur, and we can look at this and see the shape even a little bit better than what we had with the stem and leaf plot. So this tells us a lot of information. The range is from 7 to 59. We knew that by looking at the sorted data. Most of the values are between 10 and 25, and the typical middle of the data is right around 17 or 18. We also see that this is not symmetric. In other words, this tail out here, this area out here is more highly represented than what we have down here. So this is going to be a skewed distribution. We can also talk about what's called a stack dot plot, where we take subgroups of our data and make an individual dot plot for each of those using the same x-axis or the same scale. So it makes it easy to compare what's going on in these different regions. For example, here we've got central, northeast, southeast, and west, and we can see very quickly what's going on with the median sales price of single-family home. Now we're going to talk about what are called frequency distributions and histograms. Frequency distribution is something that has bins and bin limits, and basically what we're going to do is make a table by classifying the data values into the different bins. We're going to have k different. So the bin limits define the values to be included, define the values that are going to be in each of the bins, and the widths must be the same except for when we have open-ended bins. Frequencies are just the number of observations within each, and we can express this as a relative frequency if we want to talk about a percentage. So that's relative to percent, or rather relative to 100 occurrences. And we get that by dividing by the total number of observations. So one question we have to answer is, how many bins should we have? And if we have a sample size of 16, we should have 5 bins according to Sturgis, and 32, and so forth. You can see the number of bins that we should have for each of these, and that's a rule of thumb. So you can play around with that a little bit, but it's a pretty good rule. So here's what a frequency distribution looks like. Our bins have length 10. You can see that by lower and upper having a difference of 10. So 10 for all of these things. So how many do we have between 0 and 10? This is using the price to earnings data again. We got 2. What's the frequency? The frequency is the frequency is 2. The relative frequency is 2 divided by 44, and the percent is multiply that by 100. And then we can also talk about what's called cumulative frequency, where we add these things up as we go. So between 10 and 20 we have 24 observations. That's 54.55%. But the cumulative frequency says take this 24 and add to it what we had previously. So we're summing up from 0 all the way up to 20 when we talk about the cumulative frequency and percentage as well. This allows us then to talk about histograms. Histograms are just a graphical representation of the frequency distribution. The y-axis shows the frequency, or it could also show the relative frequency if we like. And then a histogram is basically just a bar chart with the x-axis showing the endpoints of each of the bins. So here's an example with 6 bins. We have this right here, 8 bins. We have this shape, 9 bins. We have this shape. So the number of bins that you have actually does have an effect on what the distribution looks like, what the histogram looks like. So how do you make a histogram with the appropriate number of bins? First of all, you've got to choose the number of bins and bin limits, and this requires some judgment. There are lots of software packages that do this for you automatically. We will be using Excel, but there are other things like Megastat, Minitab, R, SAS, SPSS, Stata, you name it. Any software package or any package that has any sort of utility was going to make a histogram for you very easily. One characteristic that we want to talk about is the modal class of the histogram, and a histogram bar that's higher than those on either side is what we would call a mode. A unimodal is a single mode that has a single mode. Bimodal has two modes, and multimodal has more than two modes. Now these modal classes can be artifacts based on the number of bins or the way the limits are chosen, or even if you slide the limits up or down. But the histogram is very useful because it helps us see the shape of the distribution. The shape is also something that's influenced by the number of bins and bin limits, so you got to be a little bit careful about that. The main thing that we're looking for, one of the main things we're looking for in terms of shape, is skewness, and skewness is determined by the fat tail, if there is one. Left skewed has a negative, or negatively skewed has a longer left tail. Right skewed means it has a longer right tail, or positively skewed. If it's symmetric, then the tail areas are roughly the same. So here's some examples. The left skewed right here, you can see this left tail is wide out here, symmetric here, right skewed out here. We got bimodal, so this is bimodal because here's a mode, multimodal, 1, 2, 3 modes, right mode, bimodal, right skewed, and here's what we would call outliers. We got a couple things way out here, and then most of the data is in here. Symmetric with outliers, we got stuff out here and stuff out here, and so once we have a histogram, we can then talk about a frequency polygon, which basically just connects the midpoints of the histogram interval. It's basically the same as a histogram, but allows you to compare multiple data sets at the same time, 2 data sets to be precise. And an ogive line is just the cumulative frequencies plotted on a frequency polygon. So here are examples of frequency polygons on the left and a ogive on the right. So notice that the frequency polygon just connects the midpoints of these things. So here, here, here. Remember, we had from the bins were from 0 to 10, 10 to 20, and so forth. So right in the middle, wherever these things are, we're going to connect. So here we had here, 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 and here. So this would represent the height of the histogram, and the ogive is going to add up the percentages as we go. So we go from 0 to 10, and we get with a small percentage, 5.44, and then when we go to 10, we get this big jump up here. So that gets added on cumulatively, and that's an additional 54%, and so forth. So this ogive is going to go off to 100%. It's going to eventually hit 100% and stick. So we're going to end this video with section 2 of chapter 3 and start up with the next video continuing from here.